Good morning, friends. Welcome to the second session of 30 problems, important concepts of geometry. Before watching this session, I hope you watched my first session on this. In that session, I covered 15 problems. Now, in my session number 2, I will cover the rest of the 15 problems. In that session, I have taken number of things, number of concepts that deals with the concept of a circle, concept of squares, triangles, and we further take some more concepts in this session. This session is very helpful for the students of CAT as well as for SSC aspirants because that covers those type of questions which are not generally covered in any classes. Let us start with the next problem. That's our question number 16. Right. The type is named as cutting of a sphere. This is named as cutting of a sphere. Sorry, it is named as cutting of a cone. Right. Suppose one cone is given to you. It is given that parallel to the base, two cuts have been made dividing the height into three equal parts. Right. Because it is given that the three parts are equal. Now he is asking that, let us say this first portion is V1, second is V2 and third is V3. V1, V2 and V3 are the volumes of these three sections. We have to find out what is the ratio of V1 is to V2 is to V3. That's my question. And it is given that these are divided equally. Okay, height is divided equally. Now what I can say, let us assume that the height to be 3. Height is equal to 3. We know that because these lines are parallel, hence all triangles will be similar, right? It means the ratio of their height and the radiuses would be the same. I may say the ratio of the height to the radius, ratio of height with this radius, ratio of height with this radius is same. Now the shortcut method simply states us that, let us say this height is 1 and this height is 2, so I may say ratio of the volume of V1 by V1 plus V2 means this plus this. You have to make the cube of that. 1 and this 2, I may say 1 by 2 cube. Right? That is 1 by 8. If it is a simple triangle and if you have to take the ratio of the area, in that you have to make a square. So here I can say 1 by 2 cube. We are getting it as 1 by 8. Right? Similarly, if I want to take that portion with a total, I may say V1 plus V2 by V1 plus V2 plus V3. Let us say this is 2 and total is 3. So I may say this is 2 by 3 cube. Or you may say 8 by 27. Okay. Right. Now what I can say? I may simply say that if this is 1, total is 8. It means that is 7. And total is 27. It means this is 19. Right. So what is my answer is 1 ratio 7 ratio 19. So I can say the ratio of the volumes of these three sections are 1 ratio 9 ratio 17. Sorry, 1 ratio 7 ratio 19. That becomes my answer. Right. Very simple questions. Because in that you have to just take care of that. Whenever we are talking about in the terms of the volumes ke andar you have to simply make the cube. Cube of the ratio of the heights. And from that you can easily answer your problem. Let us take one more question on this. It is given that one cone is there. Height is divided into three parts in the ratio of parallel to the base 1 ratio 2 ratio 3. Let us say this is 1 ratio 2 ratio 3. The height is divided into three parts 1 ratio 2 ratio 3. The first is V1, second is V2, third is V3. We have to find out what is the ratio of their volumes V1 ratio V2 ratio V3. That's my question, right? Now when I look at it, what I can say that, same concept. Let us assume total height is 6. So I may say V1 plus V1 plus V2. V1 is 1, height is 1, V1 plus V2 height is 3. So divide by 3 cube. You may take it as 1 by 27. Similarly, I may say V2 divided by V1 plus V2 plus V3. That I can say. Okay. If I say V2 equal to V1 plus V2 plus V3, so what I can say that is V1 plus V2, that is 3 cube upon total is 6, 6 cube. So I may say this is 27 upon 216, right? Now what I can say, if I say this volume is 1, this total is 27, it means this is equal to 26, and this total is 216. This is 27, total is 216. So I can say this is said to be 216 minus 27, right? If you subtract it, 16, 7, 9 and 22, 18. I may say 189. The answer is 1 ratio 26 ratio 189. So I can say that is the ratio of the volumes. V1 is to V2 is to 3, V3, 1 ratio 26 ratio 189, right? Let us take the next aspect here. That's our concept number 17 that deals with rotation. Rotating of a triangle and making of a cone. Okay, how? It is given that one right angle triangle is there to you. This is 5, this is 12, this is 13. That is given to us. It is given that the triangle is rotated along the height. Along the height you have to rotate it, right? First we are taking that is rotated along height. It means the formation that I will make, that will somewhere take in such a way. It means the kind of shape that is being made, that is in the shape of a cone. That shape is made, right? In that shape I can say that the height is 12, right? And the radius of the base is 12, height is 5 and the r is 12. If I rotate in such a way, I may say height is 5 and base is, and we can say the radius is 12. Now it becomes a cone. If you have to find the volume of this figure, so you can say 1 by 3 pi r square into h. 5 will go on 48, 3 will go on 48. You will take it as 240 pi. That's my answer, right? Same question may also be there where it is rotated along base. But we can say that now it is rotated in such a way. If that is in such a way, then we can say it becomes a cone. The shape of the cone in such a way in this structure, right? Where the radius is 5 and height is 12. Okay. If you have to find the volume, you may take it as 1 by 3 pi r square into h. 3 will go on 4. You may take it as 100 pi. So here I can say the volume is said to be 100 pi. That becomes my answer, right? And third case that we have that's different from this, that is when it is rotated along hypotenuse. When it is rotated along hypotenuse. So what is given to us? It is given that one right angle triangle is there, and this is given as 5, 12 and 13. And this is rotated along hypotenuse, right? When it is rotated along hypotenuse, so what figure I am going to make here that, suppose this is given in such a way, 5, 12 and this is 13. When we rotate in such a way, so that figure would be somewhere in this shape. That one, and it becomes a cone. Two cones are made. Right, here now, two cones are made. Right, for that, now two things I require, because I have to find the volume of it. So for that I require this side. What we need that? We need that R1, one thing we need, and then we have to also take the height. Okay, we know that this is the height is always perpendicular on the radius. So for that, first of all we have to find that R. So how we can take? We can say that the area of the triangle is half into base into height. Earlier I told you half into 5 into 12. And if I take this is the base and this is the height, so we can say 1 by 2 into R into 13. Right? We can say R is equal to 60 upon 13. So here we can say the radius of the cones are said to be 60 upon 13. So let us say this height is H1 and this height is H2. My total volume is said to be 1 by 3 pi. R square 60 by 13 square into H1 plus 1 by 3 pi R square 60 by 13 square into H2. Okay, now we know that H1 plus H2 is equal to 13. If I take this section as common, I will be left with 1 by 3 pi 60 by 13 whole square, and inside I get H1 plus H2, that is equal to 13. That's my answer. You have to just solve it now and we are in a position to get our answer. Very easy question. Now the next topic that we have done, that deals with the rotation in the structure of a triangle when it is rotated either along length or either along height, along base or along hypotenuse. If it is rotated along hypotenuse, then two such cones are being made, and in order to find the volumes, first of all we require to find out the radius. Once we have the radius, then we can easily answer it. Right? So that's our next concept, that is said to be concept number 17. Next we have 18 number concept that simply states us cube in a sphere. Cube in a sphere, right? Or cube in a sphere or sphere in a cube, right? For example, first we take cube in a sphere. Let us say one sphere is given to you and inside one cube is being there. One cube have to be there. So what we can say that the shape of the cube somewhere of this type, right? Similarly here also, here we can say that shape somewhere of this side, right? It's a cube inside it, right? Now what I can say that if you have to answer it, suppose it is given that the radius of the sphere is r, radius of sphere is r, we have to find out what is the side of the cube. Okay, now what I can say that if I assume, let us assume that the side of the cube is a, side of cube is equal to a, right? Now when side of the cube is a, so I can say that the diagonal of the cube, the diagonal of the cube is the diameter of the sphere. So when a side is a, so I can say diagonal of the cube. The diagonal formula is equal to a root 3. That becomes diameter of the sphere, and diameter is equal to 2r. I may say a root 3 equal to 2r. So from here I can say a equal to 2r by root 3, right? So what I can infer now, I can simply say that if the radius of the sphere is r, from there I can say that the side of the cube is said to be 2r by root 3. Sometime we may ask you find the ratio of their volumes. So I may say if the radius of the sphere is r, so you may say the volume is said to be 4 by 3 pi r cube, first thing, and we have to also take the volume of that cube, so you may say that is a cube, 8 r cube by 3 root 3. That you can say 3 will be cancelled out and r cube will be cancelled out and 4 will cancel out 2. I may say root 3 pi is to 2. So what I can say that the ratio of the volumes is said to be root 3 pi is to 2. That becomes my answer. Okay, let us change it. Now we take a cube in a sphere. We have taken it now a sphere in a cube, right? Now if I say sphere in a cube, so what observation we can make? Let us say one sphere is given in this way. We have taken the face of a sphere, and if you make a cube inside it, so somewhere we can say that side of the cube is equal to diameter of the sphere, is equal to diameter of sphere, right? It means, let us say if side of the cube is given to us, that is a, so you can say that the radius of the sphere is said to be a by 2, right? Okay, and if you have to compare their volumes, we can say volume of the cube is equal to a cube and volume of the sphere is 4 by 3 pi r cube a cube by 8. This would be cancelled out, 6 is to pi. So that we can say that is the ratio of the volume of cube is to sphere if a sphere is inscribed in a cube. That's my answer. So I can say that my answer is said to be 6 ratio pi. That becomes my answer. Next we have concept number 19 here. It's a very important thing, a very important concept. A cube in a hemisphere. A cube in a hemisphere where corners of the cube touches the perimeter of the hemisphere, as well as one face of the cube will lie at that base of the hemisphere. So let us say one hemisphere given in such a way to us. One hemisphere is given. Okay. Inside we have to make one cube. If you make a one cube inside it, it will be put in such a way. It will not touch at any place, right? Because that portion will touch. That one. Similarly, we make a structure of that one. it would be somewhere touch inside it. Okay, now that is a cube in a hemisphere where one face of the cube would be at this base, right? And here the 4 pointers will touch at the perimeter. Now it is given that if radius of the hemisphere is given to you, that is said to be r. We have to find out what is the edge of the cube. Our question is we have to find the edge of the cube, because once you have the edge of the cube, then you are in a position to answer each type of problem, right? Now what we think here, that we can simply think that, let us say this is the center. Okay, now from this center, if I meet to this, from the center from to me this, I may say that is r, and we can say that edge of the cube is a. It means that is the diagonal, that is said to be a root 2, diagonal of a face. If this is a root 2, I can say this portion is said to be a root 2 by 2 from here to here. So you may say that is said to be a by root 2, that you can say. But I can say that, let us say that is said to be a root 2. This diagonal is said to be a root 2 from here to here, because I am concerned with this one. Let us say this is OA. So I may say OA is equal to a root 2 by 2, or I may say that is said to be a by root 2. Okay. Now I can apply the Pythagoras theorem here. How? That is perpendicular and base. You may take it as simply a square plus a by root 2 whole square. This is equal to r square. That you can say. Now I may take it as a square plus a square by 2 equal to r square. 3a square by 2 equal to r square. And I have to find a. But I can say that a is equal to r square by 2, r square by 3 into 2. You have to root it. So what I can say, that is say root of 2 by 3 into r. That's my answer. Right. What I can say now. Now the question is very simple to us, that suppose we have that association with us. In that case we can say that if a cube is inscribed in any of the hemisphere, the ideology that you have infer here, that because that is the radius. From any point from the center, if you meet any point on the circumference of the sphere, that is said to be the radius, right? How we take that? That is a. That is a root 2, because that is the diagonal of a face, and that portion would be a root 2 by 2. It means now this is the perpendicular, this is the base, and this is the hypotenuse. So from here we can make an association between them, and here I can say root 2 by 3 r. That becomes the edge of the cube. That's my answer, right? So this, by this concept, now we have understood somewhere that if a sphere is inscribed in a cube, or a cube is inscribed in a sphere, or if a cube is inscribed in a hemisphere, how to deal such type of problems. Then we have concept number 20. It is given that a circle, a square is inscribed in a triangle. The sides of the triangles are given 10, 17 and 21, and one square is there inside it. Square is there inside it. The question here is, he is asking that what is the side of the square. Let us say this is A, B, C, D, E, F, G. It is given that D, E, F, G is a square. We have to find out what is the side of the square. The question is we have to find out what is the side of the square. Now what I can say that for finding the side, first I just draw a perpendicular here, and I try to find the length of this perpendicular. Let us say this is G, AG. How you can find out? First take the area of the triangle by the Hero's formula. Find S. A plus B plus C. 38 plus 17, 48 by 2. Semi-perimeter is 24. Area of the triangle is S into S minus A, S minus B into S minus C, right? Now, this would be broken as 24, 4 into 2 into 3, 14, 7 into 2 into 7 into 3, right? 1, 7, 1, 3, 1, 2 and 1 more 2. I may say 4 into 3 into 7, right? 21 4s are 84. So I may say area of the triangle is said to be 84, right? The next point I can say I have to find AG. I may say that the area of the triangle 84 is same as to half into base into perpendicular, right? This will go on 4. So here I can say AG is equal to 8. One thing we have inferred here, age is equal to 8. Now we can assume that the side of the square is x. Let us say the side of the square is x. Okay, if side of the square is x, it means that is x, right? And that portion would be said to be 8 minus x. Now if this is parallel to this, so we can say the ratio of the sides would be same. It means ratio of 8 minus x by total is same as to this is x by total 21. Means 8 minus x by x is same as to x by 21. I have to find x, cross multiply, right? That is 168 minus 21x, sorry, 168 minus 21x equal to 8. Okay, now I have to find x, go there, make it as 39x equal to 168, and x is taken as 168 upon 13. 168 upon 39, right? That may be cancelled on 3. I may say 3 will go on 3, 5, 15, 6, 56 by 13. Here I can say side of the square is said to be 56 by 13, that's my answer. Now it's a very standard format here. If any square have to be made in a triangle in such a way, so only if you have this process with you, only in that case you are in a position to get your answer, right? What you have to do? First find the height of this triangle. You know that height of the triangle is said to be 8. By this process we are taken to be 84. So you may say that is area half into base into height. So we may say that is said to be 8, right? Then let us say the side of the square is x. If the side of square is x, so we can apply this process, and after solving it we can say that is 56 upon 13. That becomes my answer, right? Next we have concept number 21 that states us that it deals with a square meeting the midpoints, one more square, then one circle, then one equilateral triangle in this, right? That is given to us, and is asking us that if the side of the square is 10, right? You have to find what is the side of the equilateral triangle. Side of the equilateral triangle that is being made inside it, that you have to find. That's my problem, right? Now what I can say, let us say this is 10, it means this is 5, this is 5. You may say that is said to be 5 root 2. That square that is being made inside it, because these are the midpoints, and we can say this is said to be 5 root 2, okay? Now, if side is 5 root 2, so I can say that the radius of the circle is half of it, because the diameter of the circle is equal to side. So I can say the radius of the circle is equal to 5 root 2 by 2, or you may take it as 5 by root 2. That you have got. Now this circle is circumcircle to the equilateral. So I may say, let us assume that the side of the equilateral triangle is equal to A. So we know that the circumradius of the equilateral triangle is A by root 3, which is equal to 5 by root 2. So I may say A equal to 5 root 3 by root 2, right? So we can say that side of the equilateral triangle is said to be A into root 3, sorry, A equal to 5 into root 3 by root 2. So we can say that becomes the side of the equilateral triangle that is being made inside A. So first one square have to be made inside a square, then one circle have to be made here, then one equilateral triangle is inserted inside that. So we can say if the side of that outer square is 10, so you may say that side of the equilateral triangle is said to be 5 root 3 by root 2. That's my answer. Let us take the next problem concept here, concept number 22, that deals with the concept of hexagon. One hexagon is there in such a way, right? It's a regular hexagon. Question is, let us say this is A, B, C, D, E, F. One triangle is made here in such a way, right? He's asking that if side of the hexagon is 10 centimeter, you have to find out what is the area of this triangle. BDF. That we have to find. We have to find the area of the triangle that is said to be BDF. Or EM is concerned with find the ratio of the areas, that any number of question can be there, right? So when I look at this problem, so what I can say? One thing I may say that, suppose this is 10, this is 10, this is 10. This angle is equal to, because a 120 degree, right? So what I am primarily concerned with, if I am able to find the side, because that is symmetrical figure, it's an equilateral triangle, right? So what I can say, let us draw a perpendicular here. So this is said to be 60 and this becomes equal to 30. That you can say, right? Now what we know that in any triangle, or by applying the trigonometry, you can find that easily. Let us say that is E. So what we can say that this is my base and this is my hypotenuse. So B by H, so DE by 10 equal to cos 30. That is root 3 by 2. So I may say DE is equal to 10 root 3 by 2. Or you can say D is equal to 5 root 3. That you can say, right? Now, D is equal to 5 root 2, then DB is equal to 10 root 3. Now we have got that side of the equilateral triangle, right? If you have to find the area, you may say root 3 by 4 into a square, 10 root 3 whole square. Just solve it. Root 3 by 4 into 100 into 3. You may say 25, so I may say 25 into 3 into root 3. So my answer is said to be 75 root 3. That's my answer. So here I can say answer to my question is 75 root 3. It's my answer. Means if you have any question in which you have to use the concept of a triangle inside a hexagon, so it's better first to either find the sides of the triangle, or if you have to compare the ratio of the areas, by any of the technique you can compare it. Let us take one more problem over the concept of the hexagon and a triangle. It is given that one regular hexagon is there. Let us say A, B, C, D, E, F. These are the midpoints. We have met the midpoints. That is said to be PQR, P, Q, R. Question is, what is the ratio of the area of PQR with the area of the hexagon A, B, C, D, E, F? That we have to find. Okay. Now one approach is, if we just try to find the side of that triangle, because it's a symmetrical figure, from every side we are taking the half of it, it's a symmetrical figure, right? So what I can say, I just try to find the side. If you have the side with you, you can easily answer it, and the side could also be found very easily. How? What we can say, let us say this is AB. If we meet this, because it's a triangle in such a way, let us say this is x, that would be x, that would be x, 2x. Now it's a trapezium. So I may say that is said to be 2x plus x by 2, 3x by 2. You may say px is equal to 3x by 2, right? Now you can find the area and you can compare it, right? Or what you can say, if we divide the whole figure into the small equilateral triangles, let us meet these. You have met this, you have met this, you have met all the midpoints, you have met this, right? What you can say now, meet these, all these are the midpoints. Similarly, you have met this, right? Now what we have done, we have just converted my whole structure into the smaller equilateral triangles. Now what I can say that, because I have to take the ratio of this triangle PQR, how many triangles are involved? 1, 2, 3, 4, 5, 6, 7, 8, 9. How many triangles are there? 9. 2, 2, 4, 1, 5, 3, 8 and 1, 9. Area is equal, I may say that is 9. And my whole triangles in the hexagon, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 here, 12 offside, 24. So I can say my answer is said to be 3:8. That becomes my answer. So I can say that area of this triangle PQR with the whole hexagon is said to be 3:8. It's my answer. Next we have question number 23 here. What is given to us that? It is given that one circle is there and two lines in such a way, they meet at this point, this one and this one. further given that the points are A, B, C, D, E. A, B, C, D, E. Right. Then it is given that this angle is 30 degree and this angle is equal to 60 degree. This is given to us. Now it is given that BD is equal to 6. BD equal to 6 and CE is equal to 5 root 3. This is equal to 5 root 3 CE. What we have to find out? Ratio of AC is to AD. Ratio of AC is to AD. Right. Now what I can say, this is 30, this is 60, this must be 90. If this is 90, this must be 90. Right. This is 60, this must be 120. And this is equal to 60, this is 90. That relationship I can find very easily. Now what I need AC. That for finding AC, what we need further, and we have been given this to be 6, right? If this is 6, I can find that one. How? We can apply the Pythagoras here, or we can apply the trigonometry. Let us say that ED by DB, DE by DB is equal to tangent 30. This is 6, so D is equal to 6 root 3. So I can say this is said to be 6 root 3. Okay. Now with the same trigonometry, we can say that is said to be 3 root 3. Okay, right. Now the next point I have to do here is, I can say that these triangles are similar. You can say that these triangles are similar. How? I may say that triangle BED is similar to triangle BAC. Right, because angle E is equal to angle A. Right, so I may say E is equal to angle A and D is equal to angle C. Okay, now from there I can infer, I may infer that BE upon BA equal to ED upon AC equal to BD upon BC. That you can say. Now try to take what value you have here. We have to find that AC is to AD. We need AC is to AD. Right. For that, I just try to find my values. So what I can say is that first thing I can say BE 3 root 3. That you have BA that we don't have. Let us say this is X. So you may say that is said to be X plus 6. Then further. Right. When we talk about BD, that is equal to 6. BC is equal to 8 root 3. Okay. Now from here I can find X. Let us cross multiply. 24 into 3, 72 by X plus 6 equal to 6. 6 will go on 12. So I may say X plus 6 equal to 12. X equal to 6. So you are getting this value to be 6. Right. Now I just try to find this one. What I can say that BE upon BA. BE is 3 root 3. BA is equal to 6 plus 6, 12 equal to ED. That is 6 root 3 upon AC. Okay. Now what I can say, this would be cancelled out, 3 will go on 2. So from here I can say AC equal to 24. So here I can say answer to my question is 24, because here we have to find AC is to AD. So I may say AC is 24, AD is 6. So I may say my ratio is said to be 4:1. A very general problem. Why I have taken this? Only to let you know that in a triangle, in this type of figure, when you have to make the triangle to be similar, it's very important to give the names of that triangle. Because here I can say, because this angle is equal to this one and this is equal to this one. So I may say triangle BED is similar to triangle BAC. Accordingly, we can answer it. Next we have type number 24. This question is a general statement. We have 3 logs of wood. 3 logs of wood. They have been in such a way. They have to be tied very tightly. They have to be tied tightly. Tied tightly means by a string. This is a straight string and this is a straight string. Now we can say that they have been tied tightly. It is given that if radius is equal to 5 centimeter of one log of wood, you have to find the minimum length of that rope is required so that they can be tied tightly. Okay. Now what I can say, let us say this radius is 5. This is 5, this is 10, this is 5. 5, 5, 10 and 10, 20. So I may say this is 20. From here to here this is 20. From here to here this is 20. You may say totally 60. Okay, now I need this length. So what I can say? Meet it. And similarly here I can make this way. Okay, now this angle is 90, this is 90, this is 90. Being this is an equilateral triangle, this may be 60. So I may say this is equal to 120. That I can say. And the radius is equal to 5. We have to find that one. So I may say that is said to be 2 pi r theta by 360. Okay, 120 will go on 3. You may say that is said to be 2 pi into 5 by 3. Because we have the 3 length here, 1, 2 and 3. So I multiplied by 3. So we get it as 10 pi. That you have. Now, the length of this portion is 10 pi and this is 20 plus 20 plus 20, 60. So we can say the length of the rope is equal to 60 plus 10 pi. That's my answer. We can say the length of this whole rope by which we can tie it tightly. So we can say that is said to be 60 plus 10 pi. That becomes my answer. Okay. Let us take the next problem here, question number 25. It states as that you have one semicircle. Inside the semicircle, one square is made. Inside the semicircle, one square is made where two sides of the square touches it and 2 points are on that diameter. If radius of the semicircle is 10 centimeter, we have to find what is the side of the square. That's our question. Now when I look at this figure, to here what I can say that, I can observe one thing here, that because it's a symmetrical figure, because if you have to insert a square inside that, it's a symmetrical figure. Symmetrical means it divides it in half parts. So let us say side of the square is A. So this portion would be A by 2 and this is A. If I meet this, that is equal to the radius, that is 10. So what I can say it as A square plus A square by 4 equal to 10. You make it as 4A square plus A square by 4 equal to 10. So I may say 5A square equal to 40 and A square equal to 8. It means A equal to root 8. So from here I can say that side of the square that is made inside it, that is said to be root 8. Root 8 becomes my answer. I hope the idea is clear. A very simple question in which we have just understood this concept and on that we can answer our problem. Next we have concept number 26. It talks about a square inside a semicircle. One semicircle we have. One square is being made inside it, where 4 points of the square, 1 point will lie on the circumference, 1 is at the center, 2 will be here. So we have to find out if radius of the semicircle is 10 centimeter, what is the side of the square, right? What I can say, let us assume that side of the square is A. This is A, this is A. You can say this is A root 2, right? That in return, it becomes the radius of the semicircle, that is 6. You may say A equal to 6, that is equal to 10. So here you can say A equal to 10 by root 2. So I may say side of the square is said to be 10 by root 2. That becomes my answer. Right? Means these questions are somewhere similar in nature. Only you have to just understand the conceptual, what is given to us, and over that you can easily answer your problem. Let us take the next point here. 27th. One semicircle, you have to insert one circle in such a way, right? Now same point, let us say it is given that the radius of the bigger circle is 10 centimeter. The bigger, we can say that is a 1/4 part of the circle. We can say that is a quadrant. The radius of the bigger quadrant is said to be 10 centimeter. What is the radius of the smaller circle that is being made inside it, right? What I can say, let us say this is the center, meet it, 90, 90. Let us say radius is R. This is said to be R root 2. and this is r. Okay. Now what I can say that r root 2 plus r equal to 10. R root 2 plus r equal to 10. I can take r as common. Root 2 plus 1 equal to 10. Or r is said to be 10 by root 2 plus 1. Right? So here I can say that becomes the radius of the circle that is being made inside a 1/4 part of a circle, 10 by root 2 plus 1. Then we have concept number 28 here. It's a very important question. Once it is asked in the CAT examination, by this question you can easily understand about what is the probability when sides are equal, and external angle is always equal to sum of the two opposite internal angles. What is given to us? One figure is given to us in such a way. Okay. Then this is made in such a way, and this is made in such a way. Right. Points are given. P. This is QRS. That is Q. This point is R. This point is S. Similarly here, T, U, V. Right. That is given to us. Further given that PQ equal to QU equal to US. Right. Then equal to SV equal to VR equal to RT equal to VR equal to RT. Right. Further given that this is equal to TP. You have to find what is this angle P. That's our question. Right. Now what I can say, PQ is equal to Q. Let us say this is X. This is also X. We can say QU is equal to US. Right. Now what I can say, this is X, this is X. Now this is the external angle to this triangle. So this is equal to sum of two opposite internal angles. So we can say that is 2x. Now QU is equal to US. It means this must be 2x. That you can also say. Okay. Then US is equal to SV. It is given that this US is equal to SV. It means this angle is equal to this particular angle. SV is equal to VR. It means this angle is equal to this particular angle. Okay. Now what we have taken here, that when I look at this structure, up to this structure I have taken that this angle is equal to 2x, this is 2x, and this is equal to x. Right. Further we can say SV is equal to VR. SV is equal to VR. Okay. Then VR is equal to RT. VR is equal to RT. This angle is equal to that one, and RT is equal to TP. When I say RT is equal to TP, it means it must be X, because it is given that RT is equal to TP. So I can say this must be equal to X. Now if this is X, so we can say this angle must be equal to 2x. Again, external angle, so we can say that angle is equal to 2x. Right. Further it is given that RT is equal to RV. You can say this is 2x, it means it must be 2x. From here to here, this must be 2x. Right. RT is equal to VR. Now VR is equal to SV. It is given that VR is equal to SV. Now what I can say, this is X, this is 2x. Now this angle is external angle to this triangle. So this must be 3x. Because this is 2x and this is x. It must be 3x. Next. VR is equal to SV. It means this is 3x, this is 2x. This must be x. Okay. Now SV is equal to SU. SV is equal to SU. Now what I can say, this is x, this is 2x. This is external angle, this is equal to 3x. This is 3x, this must be 3x. It means it must be x. Now what I require, because I have to find the value of x, so I need this corner angles in the terms of x. Once you have, then you can solve it. This is x, this is 3x, this is 3x. So I will say x plus 3x plus 3x. 7x equal to 180. So I will say x equal to 180 upon 7. That we have, so we can say that angle P is equal to 180 upon 7. That becomes my answer. Right. Here my answer is said to be 180 upon 7. This is my answer. Right. It's a very simple question. Once it asked in CAT examination, it seems to be a big one. Why? Because in that we have to apply again and again where two sides are equal, then sides angle opposite to them are equal, as well as external angle of a triangle are equal to sum of the opposite internal angles of the triangle. Then we have the next concept here, concept number 29, that states us that two parallel lines are there, they meet in such a way, one line is here, right? Suppose this is A, B, C, D. Let us say this is P and Q, right? What is the relationship between them? The relationship is very simple. You may say 1 by AB plus 1 by CD is equal to 1 by QP. That you can say, right? Or you may say that QP could be taken as, QP is taken as AB into CD by AB plus CD. Once a cat this question has been asked. In this it is given that this was 30 and this is 45. This was 30, right? And further it is given that is 45. We have to find the QP. So what you can say? 1 by 30 plus 1 by 45 equal to 1 by QP. And just solve it, right? Or you may apply simple that, because this is also 90, 90 and 90. We may say this side is parallel to this, hence ratio of this with total is this with total, right? Similarly, this is parallel to that one, the ratio of this by total is equal to this by total, right? From here I can easily solve it and my answer will be there. Okay, let us take the last problem of this session, that is our problem number 30. It's also a general question in nature. Two circles are there, they meet in such a way, right? One tangent is drawn here and this point is met with the point of tangency. We have to comment over this angle, right? We have to comment over this angle. Now what I can say, if I meet this point, if I just draw a tangent here, we know that from an external point, if two tangents are drawn, so sides are equal. So let us say this is x, this must be x. If this is y, this angle must be y, right? Now we know that sum of the angles of a triangles are equal to 180. So I may say x plus y is equal to 180. From here I can say 2x plus 2y equal to 180. Or else I can say x plus y is equal to 90 degree, right? It means this angle is equal to 90 degree. I hope after watching my first session on this, in which I discussed 1 to 15 concepts, and in this session I have taken 15 more different types of question or different aspect that we generally practice in geometry, and the type of question that are being asked in geometry. Watch these sessions again and again. Share these sessions with your friends so that they can also be benefited. Thank you very much.